Have we shed any light on the origin of the solar system? One theory is that the sun and all the planets and moons condensed out of the same ball of gas. Looking at the chemical composition of all these bodies, does that theory hold up, or is there maybe some other explanation?
One of the most dramatic things that we have found in the years that we've been finding these extrasolar planets is how very, very different those planetary systems are from our own. We really felt that we understood our planetary system. The small rocky planets were close to the sun when it was formed because ice couldn't condense, it was too warm. The ice would condense to form the Jupiters out a long ways from the Earth. What we found is just the opposite. We found Jupiters with 3-day orbits or 4-day orbits way inside the orbit of Earth or Mercury. The orbits in our solar system are rather circular. They're elliptical, but a little bit. These orbits are very elliptical. So it's been astounding. Our planetary system looks so different than every other planetary system we've ever seen that we're more puzzled about our own solar system today than we were 20 years ago.
That's right. You know, one thing I'm interested in is the whole culture of NASA. How do the space scientists do what they do? Is there some method of organization? Do ideas come from the top down or percolate from the bottom up? How do people work together to produce these extremely complicated projects with almost no margin for error that can't possibly be serviced after they've left the Earth?
Headquarters has a good system. Basically what they do is they want to do good science. They want to explore the galaxy, the planets, and so on. And so they advertise opportunities. And so Tony or I will see, here's an opportunity for a launch. Let's come up with a good proposal that does really great science, that makes a breakthrough. And we write a proposal, we build a team, we sketch out how this mission would go, and then we have to sell it to headquarters. And they have competition. It's typical to have 20 or 30 missions for one opportunity. And so they look at all these missions and say, which one is going to succeed? Which one is going to make that breakthrough? And only those get selected. Very competitive. But you can see it's the interplay between what headquarters brings to us, this opportunity, and what the individual scientists bring to headquarters in terms of doing the great science.
And a lot of NASA is guided by community opinion, and that's again emphasizing the point Bill's made, is that NASA headquarters, and through these calls and through what we call studies, decadal studies every 10 years, listens to the community, asks the community, what are the priorities we need to study? What is the top scientific questions we need to answer? And they use that community input as guidance. So in a large part, it is a bottoms-up percolation from the individual scientist, like Bill or myself, who say, I've got this idea and this is why it's important. And then NASA follows those ideas.
Well, this is extremely interesting because we only have about a minute left, so this is going to have to be quick. But you know, space research is extremely fascinating, but it's also extremely expensive. What is the payoff for the taxpayer? What benefits does the person on the ground receive from all this exploration?
He receives a great deal of benefit. First of all, space exploration requires very high technology. So we help our industries become technologically competitive with the rest of the world. We build the products, we invent the products, we build the jobs here in the United States. And we also, I think, provide the spirit of exploration that people in the world, in the U.S., would like. They understand better their place in the solar system, their place in our galaxy.
Great. I'm going to have to cut you off because we are out of time. I'd like to thank my two distinguished guests, Bill Barucki, Anthony Cole-Laprete. Thank you both for being here today. Thank you for watching. I'm Marty Wasserman. We'll see you next time.